Okay, using linear simultaneous equations to solve problems. Now we know that when we were doing just regular linear equations to solve problems, that setting up the equation was probably the hardest thing to do. With the simultaneous problems, again, it is going to be tricky to do this because setting up those equations is actually quite hard. And on top of that, the algebra behind this is actually a bit trickier too with the simultaneous equations. But, if you could do the simultaneous equations, then that's awesome. If you could do the setting up linear relationships or linear equations, awesome. You'll be all over this. So, to solve worded problems with simultaneous equations, what we need to do is kind of like a checklist of things to do. We're going to start off by defining two pronumerals by writing down what they represent. So for example, we're looking for things like let C, or the dollars C, be the cost of, or let X be the number of. So for example, like let C be the cost of X number of cats, like something like that. Like, the letters should represent something. And so C is usually a good one for cost. X is a good one for number. N's also a good one for number too. But, we're going to define by starting off by pronumerals. Okay, so write a pair of simultaneous equations from the given information using your two pronumerals. Pretty straightforward. Solve the equation simultaneously using substitution or elimination. So you'll actually have to decide which one to use. So remember, substitution is if you have y is equal to something, and elimination is if you don't actually have that. Check your solution by substituting into the original equations. Okay, so check whether or not the answer actually makes sense, and express your answer in words. So you actually have to answer the question. You can't just write down, x is equal to this, y is equal to that, done. You actually have to write down, the number of cats is, it's for 6 cats, it cost $800 or something. I don't know. So something with words. Anyway, example 1. The sum of two numbers is 37 and the difference is 5. For the two numbers, x and y, so they've actually already defined our pronumerals for us, x and y. So find the two numbers by completing the following steps. So step 1 is to write a pair of simultaneous equations. Okay? So in this case, we've got the sum of two numbers is 37. So remember, our two numbers are x and y. So we'll write x plus y is equal to 37. And the difference is 5. So the difference between the two numbers is equal to 5. And that's it. Solve the pair of simultaneous equations. Okay, so write one above the other to check what type you've got. Okay, not 5. The first one should be 37. Now, looking at those two equations, I'm going to be using the elimination method because I don't have y is equal to something or x is equal to something. Okay, I've got, x plus y both on the same side. Okay, now it doesn't matter if I add or subtract these two, okay, because I'll always end up with the same thing. In this case, I'm going to add these ones together. Okay, so x plus x, well, that's equal to 2x. Y plus negative y, well, that just becomes 0, so I don't have to write anything for that. And equals 37 plus 5 is 42. So if 2x is equal to 42, I can divide both sides by 2. That leaves me with x is equal to 21. Okay, so that's my first number. Now to work out my second number, I can substitute it into either of the equations. I'm going to use the first one because it has all positive numbers, and positives are easier for me. So substituting x is equal to 21, that gives me 21 plus y is equal to 37. To get the y by itself, I'm going to subtract 21 from both sides, and that leaves me with y is equal to 37 minus 21, which is 16. Okay, so x is equal to 21 and y is equal to 16. Now we need to just check our answers and make sure it's correct. So if I put these two numbers into both of those equations, it should work. So x plus y, so 21 plus 16 should be equal to 37, in which case it is. And 21 minus 16 should be equal to 5. Okay, so those two answers work. So my last step then becomes write your answer in words. So the two numbers are 21 and 16. Something just like that. Cool. All right, let's move on to the next one. So example for question 2 and 3. So the question 2 and 3 will look like this. And I recommend Oh, well, in fact, one looks much similar to the example we're about to do, and one's a little bit different, so you might need to think for yourself a little bit, which is fine. Okay, so a rectangular block of land has a perimeter of 480 meters, and the length of the blocks is 5 times longer than the breadth. Okay, so what I would do to begin with is I would actually draw a picture. Okay, this is my rectangular block. Okay, I know the perimeter is equal to 480. So that means that the outside is 480 if I add up all the outside. Okay, and I also know that the length and the breadth are like this, but I also know that the length is equal to 6 times what the breadth is. Okay. So, too many. Part A. Write a pair of simultaneous equations relating L and B. So, I've already got one of my equations already, and it's in this part here. Whoa. So I know that L is equal to 6B. So that is one of my equations already. L is equal to 6B. Now my other equation, so this is equation 1. Now my other equation, equation 2. Well, if I was to actually calculate the perimeter of this, okay, so the perimeter is equal to, it's just the sum of the outside. So it's the length plus the breadth plus the length plus the breadth. But we know what the length and the breadth are. We know that the length is equal to actually, so we can rewrite this as, so we've got 2L's, which is 2L plus 2B. Okay, so 2L plus 2B. And we know what the perimeter is. We know that that's equal to the perimeter, but the perimeter we know from up here is actually 480 meters. So I can put 480 in there. So whatever this expression is, it is equal to 480. So there's my two equations. L is equal to 6B, and 2L plus 2B is equal to 480. So question part B. Solve the pair of equations using substitution or elimination. So writing out my two equations again, I get 2L plus 2B is equal to 480, and I've also got L is equal to 6B. Now, in this case, I have an equation where it's L is equal to something, and in this case, it's 6B. So the method I'm going to be using for this one is the substitution. So wherever I see an L, I'm going to substitute it with 6B. So 2 lots of 6B plus 2B is equal to 480. Oh, not 6B, 5B. What am I saying? Because it is all 5 times longer, not 6 times longer. So if you were getting angry at me for not getting that right, well, I think you're rightfully so. So 2 lots of 5B plus 2B is equal to 480. Okay, so 2 times 5B is equal to 10B plus 2B, which is equal to 480. Okay, in other words, that is 12B is equal to 480. So to get the B by itself, divide by 12, divide by 12. So B is equal to, and in this case, it's going to be 40 and meters because it's meters. Now to work out what my length is, so that's what the breadth is equal to. To work out what my length is, I can use either one of these two equations over here. I'm going to use equation number 2 because it's already telling me what the length is. And it's equal to 5 times the breadth. So L is equal to 5 times 40. So L must be equal to 200 meters. Okay. So 200 plus 200 is 400. 40 plus 40 is 80. 2 makes it 80. And 200 is 4 times the size of 40. So last but not least, write your answer in words. The length of the block is 200 meters and the breadth is 40 meters. Just like that. Okay. Troy bought 4 bananas and 2 apples for a total of $16 at the shop. Cameron bought 1 banana and 3 apples for a total of $9. Find out how much a single banana and a single apple costs, okay? So to do this, we're going to start off by defining 2 pronumerals to represent the problem. So we're actually defining the pronumerals now. So we're not actually just jumping straight into writing equations. So what are the pronumerals that we're going to use, okay? So in the other one, it told us L and B. For this one, Well, we're talking about bananas and apples, and we are asked to find out how much a single banana and apple cost. So in this case, we'll be looking for A, which is apples, and B, which is bananas. Now, you don't have to use A and B. I could just quite as easily say, let X be equal to apples and Y is equal to bananas. But having it as A and B, whoa, that was gross. Having it as A and B is, just makes it a life a little bit easier because we know it's apples and it's bananas. All right, next we are going to write a pair of simultaneous equations relating the two problems. Okay, 4 bananas and 2 apples for a total of $16. So if I have 4 bananas and I add 2 apples, they should be equal to $16. There's my first equation. It's that simple. My second equation is 1 banana, which I can just represent with 1b, plus 3 apples, and that is equal to $9. Have a look at that. I've already got my 2 equations ready to go. Okay, which is awesome. Part C is then to solve them. So looking back over these ones, 4b plus 2a. So 4b plus 2a, and that was equal to 16. Okay. So 4a plus 2b is equal to 16. And my other equation was b plus 3a is equal to 9. Okay, so now the question becomes, well, how do I solve these simultaneous equations? Now, it looks like an elimination problem, but I can't see any numbers that have the same value. But what I do see is the fact that I can multiply this bottom one by 4, because if I do that, then I'll have the same amount of b's in both. So on the side here, 4b plus 2a is equal to 16. Okay, 4 times b is 4b. 3a times 4 is plus 12a, and equals 9 times 4, which is 36. Now, because I've got the same pronumeral, okay, so the same value or the same sign of the value, so positive and positive, I'm going to subtract these 2 equations. So 4b minus 4b is equal to 0. 2a minus 12a is equal to 10a, and equals 16 minus 36. Oh, sorry, that's a negative 10a. Negative 10a. And 16 minus 36 is equal to negative 20. Now, to get the a by itself, I'm going to divide both sides by negative 10. And that should leave me with a is equal to 2. So in this case, negative 10a is equal to negative 20. So 10a is equal to positive 20. So a is equal to 2. Okay. Now that I know that, I can substitute in either one of my 3 equations to get the value for my bananas. So I'm going to use the second one. b plus 3a is equal to 9. So I know that a is equal to 2, so I can substitute that in. So b plus 3 lots of 2 is equal to 9. Well, that's the same as 3 plus 6 is equal to 9. If I subtract 6 from both sides, I get, and I'm going to finish it over here, I get b is equal to 3. Just like that. Okay. So with that being said, I need to then write your answer in words that you can't really see. Let me do that. So a is equal to 2. Okay, and then there we go. All right, so write your answer in words. So the cost of an apple is $2, and the cost of a banana is $3. Okay, so like some pretty simple numbers, but again, it's the algebra that we want to see. We want to see you be able to actually solve these simultaneously, because that's what we are actually technically assessing. Not assessing, but that's what we want to see. Like that's what we're teaching you, how to solve the problem. Not, can you work out what numbers are, but how do you do it? Show me that you can solve them simultaneously. All right, so this is the last example we're going to do. So to enter a show, it costs adults $16 and children $8. I'll give you a hint. A, C. Pretty easy. Okay, those are probably going to be what my things are. If the total of 4,430 was collected from 320 people, how many adults and children attended? Okay, so adults equals $19. Okay, children equals $8. total equals 4430. And then the amount of adults plus the amount of children is equal to 320 in total. Okay? So that's basically going to help me work out these ones. So we're going to start off. So we've already named our pronumerals A and C for adults and children. Now, the adults are $19. So for every one A, it's equal to $19. Or in other words, if there was 2 adults, it would be 38. 3 adults would be 57, and so on. So in other words, 19A. So for $19 per adult. Plus, for the children, well, it's $8 per child, not per children, per child, and that is equal to a total amount of $4,430. Okay, so that's my equation number 1. Equation number 2 is the other one. So A plus C is equal to 320. Okay, so the amount of adults plus the amount of children is equal to 320. Whoops. So what we're going to do now is we need to solve these simultaneously. So either by multiplying, we're going to have to do it by multiplying either the A or the C, so one of the values. I think it's going to be easier to multiply everything by 8 on the bottom one. So if I times everything by 8, because I've got 8C and only 1C, I could multiply everything by 19, but 8 is just a smaller number, so that might be the one that would be better to do. Okay, so multiplying all that by 8, we get 8A plus 8C is equal to 320 times 8, which is 2,560. So now writing the equations over here again, so with the new one, so the old one, which is 19A plus 8C is equal to 4430. Okay, and our second one is 8A plus 8C is equal to 2560. Now, because the 8C and the 8C are both positive, I'm going to put a negative there and solve these ones like this. Okay, so to eliminate the C's, I'm going to subtract the 2 equations. 19A minus 8A is equal to 11A. 8C minus 8C is just nothing. And then 4430 minus 2560. So 4430 minus 2560. That's equal to 1870. Okay, 1870. So if 11 adults would be equal to that many, then 1, I'm going to divide by 11 on both sides. So A is equal to, so 1870 divided by 11, and that is 170. So there's 170 adults that turned up for this thing. So to work out how many children attended this event, okay, we're going to substitute that into either one of the equations. I'm going to do the A plus C is equal to 320 because that's a bit nicer. So replacing the A with 170, we got 170 plus C is equal to 320. To remove the 170 from both sides, subtract 170, subtract 170, and C is equal to 320 minus 170, which is just 150. So there's 150 children that have turned up to this event. Okay, so we're not done. We need to write a sentence to finish this off. So therefore, there were 170 adults in attendance and 150 children. Okay, so there we go. So that's the example for 6 to 12. Okay, so basically I'm going to set you guys 1 to 12 to do. Okay, so they're all mainly worded problems. So, you know, again, because all the word problems are different in their own retrospects, you might get stuck with some of them just not knowing how to set up your equations. Think about it logically. Look at what you're trying to find. If you're trying to find out how many adults and children are coming to the thing, your variables that you're going to be using are A and C. If you're trying to find the cost of a single banana or a single apple, B and A. Like it falls out pretty easy if you just think about it. So with that being said, we're going to do 2K. We're going to do 1 through to 12. And I will see you guys in the next video.